Geometry, Chapter 8, Lesson 1, and we want to look at the converse of the Pythagorean theorem in this portion of the lesson. We looked at the Pythagorean theorem, and the Pythagorean theorem is a conditional statement. If there's a right triangle, so if we have a right triangle, that's the hypothesis, then the conclusion would be that the sum of the squares of the legs equals the square of the hypotenuse, or a squared plus b squared is equal to c squared. Now, you remember from earlier this year, the converse switches the hypothesis with the conclusion and the conclusion with the hypothesis. So the converse would say then that if the sum of the squares of two legs is equal to the square of the hypotenuse, or if a squared plus b squared equals c squared, then you know the figure is a right triangle. So I alluded to this in the other video when we talked about the Pythagorean theorem, that if you can substitute values into the expression, making sure that the larger of the three values is in as the hypotenuse or the c squared, if you simplify it and you have the same value on each side, meaning you have a true statement, then you know you have a right triangle. And all of those Pythagorean triples that we talked about would satisfy this equation. So what we're going to do with the converse is we'll be given three lengths or three numbers that are representative of the lengths of three sides of a triangle, and the question will be, do these represent, or could they represent, the sides of a right triangle? So we're going to simply substitute them in and then see if we get a true statement. Now, all of the questions are going to require a yes or no answers and then an explanation. And so the explanation will be one of two things. Either the sum of the squares of the legs equals the square of the hypotenuse, meaning that it is a right triangle, or the sum of the squares of the legs does not equal the square of the hypotenuse. Now, it's very important that you get the wording down. I know that you probably are going to understand in your head what you're trying to say, but what I want you to be able to do is to express what it is that you're thinking correctly in the wording of your sentence. So make sure that you're careful to note the wordings, because the sum of the legs equals the square of the hypotenuse, or if you mix up the words a little bit, then it doesn't say exactly what you mean. The sum of the squares of the legs, and that's the key phrase. The sum of the squares of the legs equals the square of the hypotenuse. And again, most students stumble or have trouble writing this portion of the explanation out. The sum of the square of the legs. It's not the square of the legs. It's not the sum of the legs squared. That's different. The sum of the legs squared means I take the legs, add them together, and then square them. The sum of the squares of the legs means I square the legs first and then add them. And these will produce two entirely different answers. So when you're expressing your reason, you want to make sure that this is what you're saying in English. I know that's what you're thinking, but that's what you have to be able to say. So be careful how you state this. It is not the sum of the legs squared. Okay, that would be incorrect. It's the sum of the square of the legs. Alright, so let's do an example, and I'll show you what I mean. So let's say we have the numbers 4, 5, and 6, and the question is, can these be the sides of a right triangle? And explain my answer. Alright, so if these are the sides of the triangle, then when I substitute them into the expression a squared plus b squared equals c squared, I should get a true statement. So I'm going to substitute these numbers into this expression, making sure that the longer or the larger of the three values always goes over here, and then let's see what we get. So 4 squared plus 5 squared, does that equal 6 squared? That's the question. 4 squared is 16, 5 squared is 25, 6 squared is 36. These added together, 41 does not equal 36. So these are not a right triangle. So my answer is no, they're not a right triangle, because the sum of the square of the legs does not you don't have to underline that, but just saying, does not equal the square of the hypotenuse. And I know what you're all thinking right now. I know what you're all thinking. And I know what you're going to, Mr. Godfrey, do we have to write that out for every single answer? What do you think I'm going to say? You already know the answer, right? Yes, you have to write it out because this is practice, verbally or at least writing out what it is you're thinking and doing it in a clear, concise way. And I want you to practice that. And so I want you to practice writing this out. So either you're going to write, no, the sum of the square of the legs does not equal the square of the hypotenuse. If the answer here is yes, you would write yes, the sum of the square of the legs does equal the square of the hypotenuse. And you have to write that out on every single problem where it asks you for an explanation. Okay, because I want to see again that you can express this verbally or in written language what it is you're trying to say and making sure that you're expressing your answer correctly. So let's take the numbers 15, 20, and 25. Do these represent a right triangle? Yes or no? And then explain. So again, if these numbers are going to represent the sides of a right triangle, it must make this Pythagorean theorem statement true. So does 15 squared plus 20 squared, does that equal 25 squared? Well, 15 squared is 225. Whoops, getting a little ahead of myself here. 20 squared is 400. Does that equal 25 squared, which is 625? So these added together is 625, and that does indeed equal 625. So my answer would be yes, and we're going to write out the Pythagorean theorem in English. The sum of the square of the legs equals the square of the hypotenuse. Okay, so that's what I would expect your answer to look like.